Here we're going to talk about quotient of expressions involving exponents. So what happens, we have some different variables, different letters mixed up here, and we're having division. So if you remember from the individual cases, what happens when you're dividing two things with the same base? Well, once again, we'll first go back to just writing it out to see what does it mean. So x to the third means x times x times x. Y to the fourth means y times y times y 4 times, right? And these two things were multiplied by each other. And on the bottom, there's two x's multiplied by each other, and it looks like two y's multiplied by each other. So you end up subtracting the exponents, but why is that the case? Because you're not actually subtracting. What's happening is that they're canceling each other. Think of when you have a fraction, you're always looking for common factors. What can cancel with something else? And when they cancel, what are we asking? We're doing, what's something divided by itself? Well, if I divide something by itself, I get 1. So this really becomes 1 over 1. Probably sometimes we get lazy and don't write the 1, we just cross them off, but we're technically doing something divided by itself. So it looks like these x's cancel, these two cancel, so something divided by itself. But these two can cancel, these two, really doesn't matter as long as they match which ones. And so now if we round up, well, what do we have left? It looks like we're left with a single x on top and y times y, which we could write as y squared. On the bottom, we're technically left with 1 times 1 times 1 times 1, because everything that canceled left us with a 1. But if we have a denominator of 1, that's a whole number, so you don't have to write the bottom as 1. You can just write it as xy squared. Now if we look back to our original thing, without writing it out, could we see that's what's going to happen? Well, if we have 3 x's, 2 x's, 2 on the bottom, cancel 2 of the ones on the top, leaving you with just 1 on the top since there were more. And with the y's, 2 of them on the bottom canceled 2 of the ones on the top, which left you with 2 left over, and they were on the top. So let's look at another one. We'll go b to the 4th, a to the 3rd over b to the 5th, a squared. So let's see, without writing it fully out, if we can see what we're going to be left with. So 4 of these on the top will cancel almost all of them on the bottom, but how many will we be left with? Well, if we cancel 4 of them and we had 5, we'll have 1 left over. And where is it going to be? On the bottom, since that's where there was more of them. So b to the 1st, you can just write b if you want to also. Now here, 2 a's on the bottom will cancel 2 of the a's on the top, leaving you with 1 left over. And so since we don't have to write b to the 1st if we don't want to, we can just write this as a over b.